right? So suppose we already know that if there is a function, we can always draw a graph of that function. And if the function is like this, y is equals to f of x, that means y is a dependent variable, x is independent variable, y depends on x. When x changes, y also changes, provided y is not a constant function. And whatever be the graph, we can always draw, whatever be the function, we can always draw a graph related to that function. So it can be this or anything. Now, suppose this is what f of x is. So as you can see here, when x is changing, y is also changing, right? So this is very basic of functions and graph. So if there is a function, there will be a graph. Say for example, if I have a function y is equals to sine of x, so its graph will be like this. So this is graph of trigonometric function, that is sine of x. So x is on the x-axis and y, or a function, is on the y-axis. Now, out of these functions, we can also have some functions, or these functions itself. If you see the two functions which we have there, in order to draw the graph, I don't need to lift my pen up, and such functions are called continuous function. As you can see in the graph itself, it is continuous, it is not breaking anywhere. So such functions are called continuous function. So these functions are not breaking, or in order to draw this graph, I don't have to lift my pen up. So that's why such functions will be called continuous functions. Then what are discontinuous functions? Are there any functions which are discontinuous? So let's see another example. Suppose we have a function f of x equals to either 1 or 2. 1 if x is not equals to 0, and 2 if x is equals to 0. So it's a straightforward simple question, simple function. If I draw the graph for this, it says if x is not 0, it will be always 1, but at x equals to 0, the value will be 2. So first thing is that x equals to 0, its value is 2. And at all other points other than x equals to 0, for all other points, its value is 1. So that means it will be like this, right? And at 0, it won't be 1. At 0, it will be as we have drawn in the red line and the red dot, that will be when it is 0. So when x is 0, otherwise it will be like this. So I can draw the graph like this. Now obviously, when I started making this graph or drawing this graph, I had to lift the pen up. From this side, if I start 1 1 1, I come here and stop. I have to come here and stop. Then I have to restart from here, and then this I have to draw to represent the value of the function at x equals to 0. Now such graphs or such functions which you have just seen are called discontinuous function. So this is discontinuous function, and point this, that is x equals to 0, is the point of discontinuity. So that is the point of discontinuity, and this is discontinuous function, right? So that's what discontinuous and continuous functions are. Now moving to, or we are not going to draw this graph for every function whenever a question is asked. One, it is time consuming. Two, it is not always feasible or easy to draw the graph for every function. So some functions which are easy, for example, this function was easy, so we draw this graph, but it won't be that easy always. So in that case, what can be done? Or is there a way to find out the result of continuity, or whether a function is continuous or not? Is it possible to find out without drawing the graph? That's what we are going to see now. Next. Okay, so any function, say even in this function, right? It is actually when you are coming from the left hand side to 0, right? Its value is continuous. The only thing is at 0, the function's value is not equal to what was the value just before 0. Same thing for when you are approaching it from the right hand side, the same 0. So we can say that if you still remember the concept of limits, right? So if this is a function and we talk about, say, any point, say x is equals to a here. So at this point, the limit of function is nothing but its left hand limit and right hand limit. And if they are equal, we say that the limit exists, and that is equals to the limit of that function, right? And here what happens is, in this function, if you see, left hand limit and right hand limit are same. What will be its left hand limit? Its left hand limit will be equals to at 0. At 0, its left hand limit, as you can see here, is equal to 1. Its right hand limit is also equals to 1, but the value of the function at x equals to 0 is not equal to the left hand limit or right hand limit. So these are the points which we can discuss, or which we can conclude mathematically to prove or to find out whether a function is continuous or not at a given point, right? So in this function, through the graph, I have written here the limits. That limit will be 1 and the right hand limit will be 1, and even the limit of the function will be equals to 1, but the value of the function is different. So this is the case, or this is the situation in which a function won't be continuous. That is, there are two possibilities. If the limit itself does not exist, so what happens when, or what is the case when limit does not exist? When do we say the limit of a function does not exist? When a function's left hand limit is not equal to its right hand limit. So if this is a function, right, and this value will be its left hand limit, this value will be its right hand limit, and we say that left hand limit is not equals to right hand limit, and that's why limit does not exist. And obviously, when limit does not exist, as you can see in this function, the graph is discontinuous. So this is actually one of the cases when the function will not be continuous. That is when limit does not exist. Okay. Now, what if limit exists? The second case, the case which we have seen above, that is, suppose this is a function Suppose function is like this. So what we see here is, sorry, this is the same case. Suppose a graph is like this. So now if I have to discuss this graph in terms of limit, what do I see here is this left hand limit is actually equals to right hand limit. So I'll say that limit exists, right? So this is the left hand limit, this is the right hand limit, and both are approaching the same value. So that's why we say that the limit exists. But at that point, if you see, the value of that function at that point is something else. Value of that function is actually this dot which you are seeing here, right? The blue dot, that is the value of that function. So this is f of x and this is limit. So even in this case, the graph which you see here, the blue line or the blue curve is the graph. So in order to draw that graph, I had to lift my pen up. So what was the case? The limit existed, but the value of the function, that is f of x, was not equal to the limit. So this is the case. What is the second case? So this second case is limit exists but not equal to value of f of x. So in these are the two cases, and these are the only two cases in which a function will be discontinuous at that given x. So I hope this is clear to you. That is, when is a function discontinuous? So these two situations are there. That is, if the limit does not exist, there is no question of continuity. And sometimes limit may exist, but that won't be equal to the value of the function at that particular point. So even in that case, we say that the function is discontinuous, and the point where the limit does not exist, or the point where the limit is not equal to the value of the function, such points are called points of discontinuity. Now, a function may have multiple points of discontinuity. It may have only one point of discontinuity, and it may not have any point of discontinuity. So if a function has no point of discontinuity, such function will be called globally continuous function. And if a function has even one point of discontinuity, it will be called discontinuous, right? And the same function, if we actually apply a limit on the domain, say for example, if I restrict the domain from here to here, so from here to here it is continuous. So a discontinuous function may be locally continuous. Right? So that is another result which you should understand, that a discontinuous function may be locally, that is in an interval, continuous. So as you can see here, if I restrict the domain to this purple line or purple segment, then obviously in that segment it is a continuous function. So that's all about continuous and discontinuous functions. Let's move to some problems. Let's solve some problems based on this. Right. So the first thing, or the first problem, or there is a property actually, that if f is a real function on a subset of real numbers, and the point uh, there is a point c, and if the limit is equals to the value of that function at that particular point c, then the function is continuous at c, the same thing which we have seen above. Now let's solve this question. Check the continuity of function f given by fx is equals to 2x plus 3. So this is the function, and we have to check its continuity at x equals to 1. So we have to find whether at x equals to 1 this function is continuous or not. Right. So first things first you have to find whether the function itself exists at that point or not. If the function doesn't exist itself, then there is no point in finding whether it is continuous or not. Right. So in order to solve this, we will have to write that first the function is defined at the given point. So f of x at x equals to 1, that is f of 1 is equals to 2 into 1 plus 3, that is equals to 5. So function exists at x equals to 1. Done. Second thing, we have to find its limit. So limit of function at x equals to 1, that is when x tends to 1, that we have to find. So that will be equals to what? That will be equals to limit x tends to 1, 2x plus 1. It is an algebraic function and we know how to solve it. This will be 2x plus 3. So this will be 2 into 1 plus 3, that is equals to 5. So limit exists and limit is equals to 5. So we say that limit x tends to 1 f of x is equals to 5, and that is equals to f of 1. So that's why function is continuous at x equals to 1. So this is how we are going to solve such problems. Now this was a very simple problem, just for, you can say it's a warm-up problem, and let's move to some other problems. And let's solve one more simple problem, that is continuity of the function fx equals to x square at x equals to 0. So again, what do you have to do? You have to find what is f of x at x equals to 0. This is the point where we have to find the continuity or discontinuity. So first find f of 0. Is it possible, or is it defined or not, all such things. So this is equals to 0. So defined and defined or exist is same. Next point, what do you have to do? You have to find limit of the function at the given point, that is when x tends to 0. So that will be equals to limit x tends to 0 x square, that is equals to 0 square or 0. So again, limit x tends to 0 f of x is equals to 0, and that is equals to f of 0. So we say that this is continuous. So this is how we solve such problems. Obviously, there are very slim chances that you will get such problems in your exam, but if you get it, you are lucky and you should be able to solve it and get the marks. Next, let's increase the complexity of this problem a little bit. Let's say this is our function, that is fx is equals to mod of x and again we have to find at x equals to 0. So this mod of x, right? Mod x function is actually what? This is the mod x function, right? This is our y-axis, x-axis, and this is the graph of that function. So if you see the graph of the function, from here itself you can say that, okay, at 0, the left hand limit is also 0, right hand limit is also 0, right? And the value of the function is also 0. So the function is continuous, but we have to solve it. If you see this section, actually the graph has two sections. This section can be written as y is equals to x, and this section is actually y is equals to minus x. So this function which we have here, this can be rewritten as fx is equals to minus x and x. Minus x if x is less than 0, and plus x if x is equal to or 0, and equal to or greater than 0. Now this is the function, right, whose continuity we have to find, or we have to analyze at x equals to 0. So first is that you find the value of the function. So f of 0 is equals to mod of 0 is equals to 0. That is the first thing done. Next, the next point is that we have to find the left hand limit and right hand limit. Left hand is points to the left of x equals to 0, or points which are less than 0. So if you see out of these two, this will be used, this function definition will be used to find left hand limit, and this function definition will be used to find right hand limit. Correct? So the left hand limit, right, what will be that? That will be limit x tends to 0 from its negative or left side of the function fx. So that will be actually limit x tends to 0 from negative side, and the function from at the negative side is what? Minus x, and that will be equals to 0. That is minus 0 is equals to 0. That now coming to the right hand limit. The right hand limit, and for that what we are going to use? We are going to use the second function, limit x tends to 0 from positive side x, so that is equals to 0. So now if you see from these two, we can say that this left hand limit is equals to right hand limit, and because these limits are equal, so we'll say that limit x tends to 0 f of x is equals to 0, and that is equals to f of 0 as well. And due to this reason itself, this function is continuous. So that's in this question, right? Okay, next let's solve one more problem. Say now the function is x cube plus 3 or 1. X cube plus 3 if x is not equal to 0, and 1 if x is equals to 0. So we have to find at x is equals to 0. And normally you will say this is the point where the function may have different values. So the continuity and all we'll have to discuss at such points only. Otherwise we know that it will be continuous. So in this, generally it will be continuous at other points. Now in this case, as you can see here, you have x cube plus 3 and 1, two different functions, right? So if it is not 0, it will be x cube plus 3, whether you are moving from left side of 0 or approaching 0 from its right side. Okay, so one thing is clear, that f of 0 is equals to 1, right? Now, what is its left hand limit? So left hand limit is, again, we will do the same way which we have done earlier, when x tends to 0 from the negative side. So that will be actually this function. So this function will be used for both left hand limit as well as right hand limit. So limit of this function, and at that time the function's definition, or say this is equals to x cube plus 3, that is equals to 3. So you will substitute, this is normal algebraic expression, so you are in polynomial, so you will simply uh, put the value x equals to 0 there, and you will get this 0 cube plus 3. This is cube, right? So left hand limit is 3. What about right hand limit? That will be limit x tends to 0 from positive side fx, and actually that function also is also same, that is x cube plus 3. So this is also 3. So what do we see here? Limit exists. LHL is equals to RHL. So that means limit when x tends to 0 of this fx is equals to 3. But that is not equals to f of 0, which is actually equals to 1. So this is discontinuous. So that was an example of a discontinuous function, and how we are going to find whether that function is discontinuous or not. I hope you guys understood how to solve such problems. Let's quickly solve few more problems, and that will finish the continuity topic. And a function which is, for which you are not able to find any point of discontinuity, that function will be always continuous function. So the mod x function which we have seen above, that is actually a a continuous function, that is always continuous function. Let's see. Let's say we have a function f of x is equals to x cube plus x square minus 1. So this is the function, and from this we can easily say that it is defined for all functions. We have to find, in this question you have to find whether this is continuous or not. So when such things comes, that means it is not given, we are not given any point of where we have to find its continuity or analyze its continuity. We are simply asked whether this function is continuous or not. So in such cases, we have to come up with this. We have to actually try to find out if there is a point of discontinuity or not. If there is no point of discontinuity, then that function is a continuous function. So what do we do here is, we assume the function to be discontinuous at some point C, right? So say at point C, the function's value will be what? F of C will be equals to C cube plus C square minus 1. And at the same point C, what will be its limit? That will be limit x tends to C f of x, that is equals to limit x tends to C x cube plus x square minus 1. And what will be that? That will be C cube plus C square minus 1. So for any arbitrary point C, what did we observe? At any arbitrary point C, the fx value and the limit value are same. So that means this is always continuous. Right? So that's what always continuous functions are, and that's how we are going to find whether the function is always continuous or not. Right? Whatever our functions are. Okay, let's move to next question, where the function f of x is given by x plus 2 or 0 or x minus 2. X plus 2 if x is less than 1, 0 if x is equals to 1, and x minus 2 if x is greater than 1. So in this, again, we have to find whether it is continuous or not. So even in this question, what we have to do is we have actually in the definition itself, there is a point x equals to 1. So before x equals to 1, it is a polynomial x plus 2. After x plus 1 also, it is a polynomial x plus x minus 2. But only at x equals to 1, it is a real value, that is x equals to 0. So at x equal and so x plus 2, if I have to draw the graph for this function, right? How will be the graph look like? So at x equals to 1, it is 0. And after x equals to 1, it is x plus 2. That means if it is if at x equals to 2, it will be 4. At x equals to minus 1, at x equals to say minus 1, it will be plus 1. Okay, and at x equals to minus 2, it will be 0. At x equals to 0, at x equals to 0. What happened? At x equals to 0, 0 is less than 1, right? So this function will come at x equals to 0, it will be 2. So if we see this graph, right, at x equals to 0, it will be 2, and x equals to minus 2, it will be 0. So this will be actually a straight line passing through these 2 points. correct? Only thing is that x equals to 1, I have to stop. So I stop at x equals to 1, because at x equals to 1 it is 0. So at x equals to 1 it will be 0. So stop. Now after that, that is when it is greater than 1, when x is greater than 1, say for example any other points, say x equals to 2, it will be again 0, correct? So, and at x equals to 3, it will be 1. At x equals to 4, it will be 2. At x equals to 5, it will be 3, and so on. So the same graph in the next section will look like this. I hope all of you understood this, that at x equals to 1, the left segment stops and the right segment starts. But at x equals to 1, the value is not that, value is actually 0. So the graph looks like this. And from this graph, what we can conclude is that the function is discontinuous at x equals to 1. And even its left hand limit and right hand limits are not same. From the graph itself, if I ask you what is its left hand limit and what is its right hand limit, so left hand limit is equals to actually this point. So this point is what? This point is 3. So left hand limit is 3 and right hand limit is -1. So left hand limit is not equals to right hand limit. So limit does not exist. And same thing you can do without using the graph as well. So try to solve these questions with graph. I have already done. Without graph, you try. And that's all for the day today. We'll continue our next class at 5. That will be for physics. Okay. Okay then. So I'll